Hi, this is Coach Brian from the National Faceplate Society in partnership with Science Olympiad, bringing you a demonstration of a super simple, super cheap torque meter construction. It's made of 3 paint stir sticks and an 020 plain steel guitar string. Paint stir sticks from Home Depot are available free. From Lowe's, you can get a 3-pack of good quality sticks for $1.98. Or if you can't get paint stir sticks, you could get 1/8 inch craft plywood 12 by 12 sheet or 6 by 12 sheet at Hobby Lobby for $2.99. The plain steel guitar string I'm using is a GHS ball end electric acoustic guitar string. 020 is the thickness of the string, 20 thousandths of an inch. And it looks like this, plain steel ball and guitar string. It's 41 inches long, so there's enough wire there to make 2 torque meters actually. You can get a GHS plain steel ball and guitar string for $1 to $1.50 from a whole bunch of different guitar outlets. If your local guitar store can't get one for you, and you have to order mail order, the shipping is only about $4 because it fits in a basic envelope. The torque meter is the most important tool for a flight event to do good quality science, get better flight times, and avoid airplane damage. The basic benefits of using a torque meter include data analysis. Torque data is the primary data needed to improve flight times. Maximizing performance. Torque data lets you get maximum turns in your rubber band motor while minimizing risk of motor breakage, which leads to great flight times again. Consistent flying. Torque data is critical to fly the same in competition as in practice. Airplane damage prevention. The launch torque value predicts the climb height very accurately to avoid ceiling hits and damage. And rubber variance control. Typical package of a common rubber band thickness used 0.94 inches for the event this year and last year. That rubber varies as much as 5% along its length. So one batch of rubber, one package will not be the same as the other. And without torque data, this variance will result in too high or too low climb pretty much every time you change motors. So torque data is very important. It's, I would say, just as important or more important than the airplane itself. So the materials list is in the video description, but it's basically 3 paint stir sticks. These are good quality stir sticks, so they are 1/8 inch thick, usually pine wood with nice square edges. So you can get a cheap stir stick, and that won't work as well. It's got rounded edges. It's really thin wood. It's warped a little bit, so don't get those. These are available from any good hardware store or paint store, so look around, get the right stir sticks. 020 plain steel guitar wire, again, I showed that to you. Needle nose pliers are necessary, and something that'll cut wire. Medium CA glue, super glue, fresh glue, and Gorilla Glue or Elmer's Carpenter's Glue for gluing the paint stir sticks together. And a little bit of carpet thread, heavy thread, or Kevlar fishing line works even better. There are pictures of the cutting and gluing of the paint stir sticks in the description of this video. And there's also a copy of a document you can get this torque meter dial out of and just print it right out. Darken it a little, and I shrunk mine to 90% so that it fits well on my particular paint stir sticks. Again, get good quality stir sticks. The sticks I found are 1 1/16 inch wide. That's about right, and 1/8 inch thick. In order to make nice perpendicular cuts, because you're going to cut the stir sticks to 10 inches long. This is 10 inches long. You can make your own little square like that by cutting a piece of cardboard and using a protractor so that you can draw a straight line and make straight cuts. Fine-tooth saw is handy for making these cuts, but any saw will work. This is a razor saw. You may have that for your other events, like the tower event this year. Ruler is handy for the gluing and all the various measuring steps. And I'm going to show you how these glue sticks were glued together, just kind of a fake demo, because I did this last night and let them dry overnight. So basically I took the stir stick after cutting it off, put a bead of Gorilla Glue along one edge, put that against this ruler, which is pinned, braced on one edge, put the other stir stick up against it, and then to put pressure to hold that joint together, I took another pin block, and these are just pieces of 1/4 inch, 1 inch by 1/2 inch balsa wood, and these are just regular pins. They have a funny, interesting plastic end, so I'm pressing it together. So that's the way you can clamp this to make both the front and back of the torque meter and also the base. So the base sticks are 10 inches long. These front and back faces of the torque meter are 2 1/8 inches, just to basically make a square, because these are two 1 1/16 sticks, so 2 1/8 this way, 2 1/8 that way. So this is how it was braced while the glue dried overnight. And this was Gorilla Glue original. You might be able to use super glue for this, but I wanted something just a little bit tougher. So that dried overnight, and then the pinning and bracing like that is done. You'll want to print out your dial face. Again, I had to shrink mine 90% on my printer. Depending on how wide your stir sticks are, yours might work fine like that. I also darkened it a little bit, so it came out a little bit darker. Also, the little support triangles are just 1 1/16 by 1 1/16, which is the width of the paint stir stick, so that was easy. And a little drawing on how to cut those out is shown in the description. So the first step after you have the base and the front and back cut and glued together will be to punch holes in the front and back face plates. So I just used a number 16 T-pin, which is about 0.30 inches thick, pushed the pin through, measured first, of course, to find the exact center point. So this would be the front, hole in the exact center, and then I wiggled it around to make it a little bit looser fit. And then with the back plate, there's a hole in the center, and then also a hole which will be a 1/2 inch up from the center. So you'll see what that is for as we get going. So after you've got the front and back face plates put together, the dial cut out and ready, and I cut it very carefully so that it fits really nicely on the faceplate. So take your time on that. And I poked a hole in the dead center of the piece of paper that I'll line up with the wooden faceplate later. So then you need 15 inches of wire, guitar string, and you can see it is slightly curved. You can fix this, it doesn't have to be perfect, by gripping it with your needle nose pliers and then just stroking the wire like that. And that will remove some of the curve. It doesn't have to be perfect, and you can roll it just a little bit, and you can get a little bit of that curve out. Gripping it with the pliers allows you to stroke it, and it doesn't roll on you. So that's a little bit straighter, and that'll work fine. So the first bending step is to bend 2 3/8 inches of one end of the guitar string completely over on itself. So the first step will be to bend it 90 degrees, and then to grip it just a little bit away from the bend and get a little bit sharper bend. And now to fold it over on itself, I'm going to hold it like this and squeeze again, and maybe again, and till it's folded over completely. All right. The next step is to form the, we'll squeeze you just a little bit tighter. All right, good. Is to grip the hook, grip the end that you just folded over a 1/2 inch from this tip. So you can see I'm using a ruler and I'm gripping it at a 1/2 inch. And I'm going to bend that initially 90 degrees again. And then I will grip it a second time, just a little bit away from that bend. That's so that I don't create a rounded edge as I push it around the pliers. And I'm going to sharpen up the bend angle. And what I'm shooting for is 120 degrees. So I already used a protractor to draw a 120 degree angle on my piece of paper. And I have wax paper on this piece of paper so that I can protect it from the gluing steps. All right, so that's very, very close to 120 degrees. I might back it off just a touch. All right, we have 120 degrees. The next step is on the tip of this angle. I'm going to grip the wire at a 1/4 inch. And we'll do it like this. And I am going to bend that last 1/4 inch. So I'm holding it at a 1/4 inch. Bend that last 1/4 inch another few millimeters. So I have something that looks like that. So over the course of doing these bends, you can see that things got a little bit uneven. So I'm going to fix that by just bending one of the doubled wires here, just a little bit. There, and we're a little more even. That's going to work fine. All right, the next step is to measure 3/4 inch from the point of the hook. So the point of the hook, I'm going to measure 3/4 inch, grip it at 3/4 inch, and then I'm going to bend the short wire of this 2 3/8 inch up so that it is in line with the hook. So as much as I can. And that's going to be a 90 degree bend. All right, so the hook looks like that. All right, we'll put a little file folder there so that'll focus a little bit better. You can see what it looks like. All right. The next step is to get a little super glue ready. And I could have done this before we started the video, but you can see I'm putting some super glue on a piece of wax paper. Let me get my kicker ready. A little bit of kicker in the cap. And I'm going to take my piece of thread and I'm going to wrap it tight to where this is the pointer 90 degree angle joins the hook. Actually, before I do that, I will get just one drop of glue right there where that pointer bend and the hook happen. And then I'm going to hold the thread there for about 30 seconds. If I had a spare hand, I'd put a dot of kicker on that, and that would dry right away. You don't have to use hit kicker, but it just means that you have to hold the glue joints just a little bit longer to make sure that they bond. I think I will use kicker on this. All right, one dot of kicker. All right, now we're bonded. All right, now I'm going to wrap this thread 4 or 5 times going up towards the hook, and also tight up against the pointer. And one more drop of glue. All right, one more dot of kicker. All right, you see I'm just using a toothpick and dipping it into the kicker. All right, then we can cut that off. Might cut with scissors, might also be easier to cut actually with a blade. So we'll cut it with a blade. All right. We'll cut that a little bit cleaner later. All right, so then we have our hook. And this is not quite 90 degrees. We'll give it just a little push back. All right, there we have our hook. Okay. The next step is going to be to mount the faceplate onto one end of the 10-inch base, the front faceplate. So when mounting the front faceplate, we're going to mount it with one of the triangles, one of the support triangles, at the same time the faceplate is attached. So the faceplate will be attached to the very end of one side of the base, and one of the support triangles will go on one edge of the faceplate, like that. I'm doing the support triangle and the faceplate at the same time so that I know that the faceplate is at a nice 90-degree angle. So I'll put a bead of glue there, a bead of glue here for one of the support triangles, and a bead of glue here where the other edge of the support triangle goes. Okay. All right, then I'm going to hold that for about 30 or 40 seconds, and then I'll hit it with a little bit of kicker. All right. A little bit of kicker. All right, good. Then we'll put the other support triangle on for the front faceplate. Also, I'm going to hold that for about 30 seconds. And we'll hit that with a little bit of kicker also. All right, so now you have the front faceplate attached. The next step is to use a little bit of glue stick. This is what's going to hold the dial face onto the front faceplate. A little bit of glue stick all over the front faceplate area. And any of the reasonable quality Elmer's or Uhu or Gorilla glue sticks will work fine. Next we will take our torsion wire with the hook bent and we'll slip it through the hole in the dial, and we'll slip that through the hole in the front support, and then that'll help us position the dial so that we know that the hole in the piece of paper and the hole in the front support are lined up. All right, so get that attached nice and securely. All right, and the next step is to slip the torsion wire through the front faceplate and then slip the torsion wire through the back hole in the rear faceplate. Oops, missed a step. We have to know where to bend the wire. So the torsion wire element needs to be 9.5 inches long. So we have to make a mark on the wire at 9.5 inches. So we're going to measure from where the wire is mounted to the pointer part of the wire and pointer. And we're going to get 9.5 inches. And then we're going to make a mark with a Sharpie so that where the mark edge is, back edge is our bend point. So the mark can be kind of fat so you can see it, so that you can see it on the wire. And to make it even easier, I'm going to make the mark go all the way around the wire. So I'm rolling the wire and making the mark. And you can see I have a low mark, and I'm going to bend so that the bend happens right at that 9.5 inch point. All right, now we will put the wire through the front faceplate, wire through the back faceplate so that the additional hole is above the center hole. So it's going this way. It could go the other way too, but you'll see what that does for you in just a minute. Okay. So this is not being glued. The back faceplate is not being glued yet because we have to make another couple of bends. So I'm going to bend now at the 9.5 inch mark. So I grab it at the 9.5 inch mark. I'm going to make sure that my pointer wire is on the 0 point so that I can make this bend so that this bend will be parallel to the pointer wire. So I bent that 90 degrees so you can see pointer wire is at the 0 point. The rear support bend 90 degrees is parallel to the pointer wire. Pointer wire at 0, they're basically the same. It's not perfect, but we can fix that in just a minute. Okay, you want a little better 90 degree angle than that so that the wire will sit nicely on the rear faceplate as it's glued. All right, then the next bend is going to be 1/2 inch because the second hole is 1/2 inch above the first hole. I want the next bend to go at 1/2 inch above this bend. So this bend will be also in line with the torsion wire. So you can see the bend looks like that. All right. So that bend will go in the upper hole of the torsion wire, and then I'm going to test fit and see how everything looks. It looks pretty good. The wire is going to sit pretty flat on the back of the back support of the torque meter. All right, so now to know where to mount the back support of the torque meter, you want to mount it so that there is a few millimeters, maybe 1/8 of an inch of space between the wire, that is the pointer, and the front face, so that that won't drag on the front face. So there's a little bit of space right here. I'll show you what I mean. A little bit of space like that, so that the pointer needle won't drag on the faceplate. All right, so that tells me where I should locate the rear support of the torque meter. And once I have that determined, I'm going to make a little mark. So there's my mark. And then I want to make a nice straight line for me to follow when I glue the rear of the rear plate. So you can see I made this little 90-degree square using a protractor and a little piece of cardboard. All right, so that's the line I'm going to attach the rear plate when I glue it. Then we'll just test fit it one more time to see how that looks. And it looks pretty good. So again, I'm going to attach the rear plate with one of the support triangles so that it'll keep it at 90 degrees. Nice fat bead of medium super glue. And then I'm going to put the support triangle here. So a little bit of super glue there, a little bit of super glue there. I will line this up on my line that I drew. And I will get the support triangle, put it into position so I know that my back plate is at 90 degrees. It looks pretty good. Hold it for about 30 seconds. And I glued my finger with the super glue. A little twisting action will minimize the amount of skin that you remove as you pull your finger away. Notice that twisting action. That's how you pull your finger away with super glue binding fingers to parts. Again, a little kicker. I'll be sure this is pretty sturdy because I am going to put a little force on it as I put the other triangle down. All right, kicker's applied. And we'll put the other support triangle in place. All right. Hold it for about 30 seconds. All right, and we'll give that a little bit of kicker also. Okay, And then the last step is we have to glue this wire to the back of the faceplate. You don't absolutely have to do it, but I want this to be pretty secure. So again, we'll put a decent little blob of super glue here. And so that I can hold that wire in place while the glue dries, I'll put a little piece of wax paper here to protect my finger. The wire is a little bit slower to bond with super glue, so I might hold that like 40 seconds or so. All right, that's it. You're done. You can see that the wire is not perfectly lined up, so you can just hold on to the hook, give it a little tweak. Just bend it just a tiny bit. Now once the rubber is pulling on the hook, it's going to be nice and straight and at the 0 point. So there you have a torque meter, and then I'll just trim this little bit of extra wire off and curve it back so it won't poke anybody. So there it is, super simple torque meter. You can clamp this torque meter onto the table with a couple of C-clamps, or if you want to do something that my teams do, it seems like it's a little bit not very fancy, but we'll put a little block of wood here, a little piece of 1x2. We'll put an eye bolt in that, and then we'll bend a coat hanger. So this coat hanger is designed to go around the edge of a table, and then it just slips into this hook, into the eye bolt, and that holds it on the table. This is a little bit handy because if you don't have a table, you can rebend this and you can hook it into metal support for the spectator stands or through a wire grate on the floor, near the floor of the gym, or other things like that. So it doesn't seem very fancy, but it's actually quite functional if you don't happen to have a table where you are. So this is a J&H torque meter, by the way. That's another good one. And other companies like Freedom Flight and Laser Cut Planes also sell good basic torque meters. So that's the super simple torque meter build.